Hello everybody out there. After a very trying day of travel, I'm happy to be here in Denver at the Denver Beer Company, but I'm also happy because I get to meet up with a good friend of mine and a good friend of vBrisket, Matt Brender. Matt?
Hey John, it's great to be with the vBrisket gang yet again. I'm Matt Brender. I'm a developer advocate at Intel. So I work on software-defined infrastructure and talking about some of the cloud-native application architectures that people are migrating to. So it's been really fun to come from a VMware background and go where a lot of us are going, kind of into that future dev.
Okay, cool. When we were talking about this before, a lot of what I like where you're covering there is, a lot of what I consider a new paradigm, and it's interesting to talk about because, we're on a road trip to, the most prominent virtualization platform for x86 virtualization, and where that has a large market share. What you're talking about is kind of the next wave. You want to kind of go into that a little bit?
Well, yeah, and there's something about it being like, I don't even like to consider things like previous wave, current wave, because I like to start from a stance of being very practical and realizing that what we're talking about when we talk about virtualization and VMware in particular is a reliable architecture that has gotten us running most of the world's infrastructure on a virtualized platform.
Very good point.
That's incredibly cool.
Yep.
And what's been particularly cool from it, as I've joined Intel and learned about what we do, is that's accelerated by our ability to show silicon value all the way up into the virtual machine.
Oh, that's good.
So understanding these layers and basically how hardware is driving software and how software paradigms are driving hardware, that it's actually a closed loop and we're both affecting each other, I think that's incredibly cool.
I like it. I love it. So why don't you talk a little bit about the project in particular, Snap?
Yeah, I love to, man. So what I've been working on is called Snap. It's a telemetry framework. Telemetry is kind of a weird word, so I like to break it down to what it really is, which is collecting information from certain sensors and processing that and then publishing it to endpoints. And what that's really valuable for is a few different things. The basic one is operations, that if you can monitor things and see the information, the statistics from different layers of your architecture, that's incredibly empowering to your infrastructure team.
Huge.
That gets incredibly cool when we start thinking about this new paradigm shift where we're more directly interacting with our schedulers. So let's take Kubernetes as a great example. Kubernetes scheduling can be affected through information from telemetry. So if Snap is put into the right place in the infrastructure, I can consume information about what resource utilization is happening on a per node basis, feed that into the Kubernetes scheduler, and more intelligently orchestrate the cloud-native applications I'm deploying to my infrastructure.
That's really cool.
Yeah, so like, long story short, it's like some of the operations of infrastructure can get more automated, and operations engineers can go back to what they do best, which is really be foresightful and looking into where we need to develop into, as opposed to doing that day-to-day optimization work.
Yeah. Well, and actually, I just had a thought here, and I'm probably breaking like the first rule of interview because I'm just going off the seat of my pants here, right? But do you watch Silicon Valley on HBO? Okay, so
I do, yeah.
Yeah, the whole idea of neural netting, right, is all part of what you're talking about. And what's so cool, right, and it's kind of like we could talk about that, and it makes sense, and you don't necessarily need to worry about the consumers not understanding it, like with Pied Piper,
Yeah.
We're here to do the whole background and encrypted charting, and how that all got together. But that whole idea of making things that are not only automated, but technically get smarter over time is really exciting. I mean, it really is.
Yeah, and what I like is that doesn't leave the operations type people like ourselves out of the picture. That humans are great at higher level reasoning and seeing patterns that aren't easily coded.
Right.
But what coding is good at is ensuring consistency and ensuring a continual improvement when you can tell it what improvement is. Like, you have to define improvement, and then code can do it better than we can.
Right.
Because we are not diligent, we are not great at doing things the same way over and over and over again. So it's like, what I think we're really getting to is the position where infrastructure is being optimized for what computers do better and what humans do better.
Right.
And it's actually going to make all of our jobs a lot better if we go this direction together.
Yay, machine learning, right?
Yeah, I mean, but the right amount. Like, let's be serious. Like, anomaly detection is a really sexy phrase right now.
Right.
But what does that mean? It's actually really confusing to figure out the definition of an anomaly and the definition of what learning is in a business logic way. So for a very long time, we're not going to be at a point where that is the thing. What computers can do really well is basic statistics that we're too lazy to do. And what humans do really well is figure out what an anomaly is before it's even defined as one.
Yep.
So like, let's play to both of our strengths and continue to make a more fun, more dynamic work environment.
Right. Yeah, I do have to say that I'm really excited that we're in a place where anomaly detection is a sexy phrase. I do want to say that. If anybody else goes on YouTube and listens to this, they're going to be like, what?
No.
Yeah.
But I mean, I think that's what's cool about being in data center technology, that we sometimes have the unsexy definition of being the plumbers of the internet. Like, we're dealing with all the piping and stuff so that people can just flush the toilets on their phones and not worry about what's happening. But in reality, like, there's a lot to it. We're evolving very rapidly, and there's a lot of work we can do and make our lives better, and also continue to build incredible systems. So I think we're in a good place.
So the stickers that you're handing out, which I love the logo as a lover of art, you know, and you know, amateur logo design. That's not amateur, but I love the logo. On the stickers, I did see a GitHub link. Is there any links or anything you want to share with anybody?
Sure. I'd love to point people to snap-telemetry.io. Okay. That's a landing page for it.
And I'm hoping I can do this in post, but we're going to put it right here.
Yeah, and where, if you go to there, you'll get the story of why telemetry can be powerful to your data center, but also download and start installing Snap. Or if you're getting into Go development, it's primarily written in Go. I've gotten to code with some really interesting people lately and kind of break that barrier between operations and development. So we've been building really cool plugins for it so that we can continue to expand. And I'd love to continue to grow the community with like my favorite people, which include Brisket fans and include a lot of virtualization people.
Well, thank you for your time. That's part of the reason why we love you here at vBrisket, and we're super excited. He's jumping on the bus with us.
Yeah,
he's a hero in our minds and hearts. So thanks, Matt, and it's good spending time with you.
Yeah, thank you, John, and thank you so much for listening.
All right.